Last week we talked about endless runners from the perspective of parallax and also getting the character to jump around on the screen. And there was I thought a fairly lively discussion around both topics. Everybody had a kind of a different take on how to do it, which I thought was great. So if you haven't seen that video, be sure to go back and watch last week's Corona Geek Hangout for that. But I think we wanted to continue the discussion this week and look at things like scoring, and if you fall into a pit, how do you handle that? And things like that.
That's my life right there.
If pit, run, function, die, something, I don't know. Yeah, so and anyway, so I think Ed was going to take us through some of the extra bits. And
yeah,
if you guys,
Ed was going to take us. Ed got all wrapped up in the Corona cards and HTML5 discussion and stopped bringing up his demo.
That's okay.
So that means you guys should talk for 2 seconds while I get this running.
I will. So if anybody on the panel has insights or wants to throw in on how they've handled these types of things, please do speak up, because it was very interesting last week to see how everybody handled something a little bit differently, right? It seemed like everybody agreed on the overall mechanics and the overall concepts or challenges that went with each piece of development. But then, just as always happens with programming, there's different ways to approach it, and it was good to see all the different approaches. So,
am I visible yet?
You are visible as opposed to invisible.
Go ahead and keep talking. I'm bringing up the right code.
We can see your screen, yeah. So now, and also as a reminder, Ed did post this, and we'll put a link in the show notes. He posted a link to this out on GitHub, so you can actually pull the code down and dig through it yourself if you want. And I'm assuming, Ed, you're giving everybody permission to reuse it in various ways.
Reuse it, do whatever they want, tear it apart.
Once it's out on GitHub, it's like yeah.
It's out in the wild. You pretty much can't do anything about that.
It's in the wild.
My only disclaimer is I always ask people, don't just give it away as your own and say, yeah, I made this and whatever. So
yeah, right.
Do something with it, learn something from it, change it, modify it, whatever. That's all cool.
Yeah, there was some videos. I'm sorry, I can't remember his name at the moment. I apologize to him. But if you Google on YouTube Corona SDK Flappy Bird, one of the community developers who went out and created like a 7-part series on how to develop a Flappy Bird game using Corona SDK. And one of the things he said in his very first video was, don't just publish this as another Flappy Bird game, right? It's a tutorial so that you can learn and implement different things into your next app, but don't just copy paste.
Speaking of Flappy Bird. You gave me an opening.
Hey.
Well, now, one thing. I just want to say I heard a statistic just a couple days ago. I don't know if this is still true, but at one time, and maybe it's just recently, there were up to 50 Flappy Bird clones being submitted a day. Yeah. To the store, to the Apple Store alone.
I wouldn't doubt it, because I've actually gone searching for different keywords that had nothing to do with Flappy or Bird, and you can find variations of that theme in just about any kind of genre.
Yeah, it's crazy.
Yeah.
All right, so basically, where we left off, if I don't mess up my screen, so you should be able to see a full view of my screen with the game running.
Yes.
Where we left off was we had already dealt with the platforms moving in from the right and the player. Let me start that again. Our little player here and how to jump and all that good stuff, but we had not talked about tracking the distance that you run, which is one of the mechanics in an endless runner, and what happens when you fall into a pit. So this will actually be a pretty short talk. The distance meter is nothing more than a counter that starts running when the game begins. So as soon as the ball drops in, the counter starts. And if you're a bad player like me, it's over already. And what I did there was, the way the rest of the game works is you set up a velocity for the platforms. So I go to the top of the file that comes with the game, or the downloadable game. Where is it? Never find something when you're talking about it.
Velocity is usually direction and speed, right? I mean, that's what the
right. So actually, this is just a speed in the horizontal dimension. So in the X, I'm just talking about the speed. So the default speed for the game is 50, but the way it's run is at 150. So it's moving at 150 pixels per second, right to left. And what I did here is let's make this a lot slower so we can see what's going on. I'll run it at 10, restart the game, and of course it doesn't work. I don't know why. I'm in the wrong section. Good job. Let's try that again. Okay, so it's blazing along. As you can see now, the distance meter is slowed down.
Okay.
So all this is as soon as the game starts, I've got a bit of code which I'll show you. Let's find it. First, I create a text object here, and I set the value to, I say distance and 0. It's just a string, and then I keep the handle or a reference to it. And then later on in the game, I set up a enter frame listener, and I pass this function name to it. And what it does is, assuming that the game is still running, it checks to see if the game is running, and I have a flag out there that's set to false as soon as you fall into a pit. It just checks the current time, and then it multiplies, let's see, building speed is the is a variable that gets set when I run this, and it's basically the left to right velocity, the speed that I was talking about. So right now this is set to 10, as I set it right here. I passed in 10, and I won't go through the code, but up above it gets set to 10, and then I basically subtract the start time from the current time, divide that by 1,000 because it's in milliseconds, multiply that by the speed, and then the only other thing I did here was I added a slight modifier because, let's go to the top of the file here. Sorry about this. If I leave my modifier, if I had it as if there were no modifier, and then I run the game, so it's just cranking along here, you can see that it's not moving very quickly, and yet my distance thing is like, it's really going too far. It's too much. So my point here is the distance you travel is whatever you want it to be in your game that feels right. And so for me, I wanted to kind of slow it down a little bit, so I put a modifier in.
You mean it's not to scale?
Say again?
It's not to scale?
No. Well, there is no really. There's no scale, right? What does it mean by scale? I mean, in Corona, it's all measured in pixels. It's not in meters or feet or. So you have to choose what 1 pixel means for you.
Well, how tall is an iPad?
Which one?
No, I'm just, that's what I'm saying. Like, you go, well, the iPad screen's 7 inches, you know?
Yeah, well, okay. So, again, what is our distance meter? It's basically just a text object in this case, and distance is measured as time multiplied by the rate for which we've set our game, which is now 10. It's just a value. And then I multiply that by 0.25 to shrink it down a little bit, so it seems a little more realistic. So if I pump this back up to 150 pixels per second and play it, it's got a more realistic feel. So I'm moving relatively fast, and it feels like the meter's not just climbing like crazy.
Hey, Ed.
Yeah.
Why do you factor in time in your calculation of distance?
I factor in time because, sorry about this, when I pause it looks really weird, but everything in my example here is based on one value, which is 150. The platforms move at a rate of 150 pixels per second right to left. The gaps, which you can't see them here, move at the same rate, so they keep up. And then the parallax background is some factor of that, but that's irrelevant because it's just fluff for the background. So the key element here is the way this is implemented, the player is actually staying in the center of the screen all the time. It's not moving at all.
Right.
It's the world that is moving behind or in front or underneath, however you want to think of it, the character. So my game speed is 150. So distance is a factor of that speed. And then that speed is applied as a factor of time. In other words, move at 150 pixels per second. So does that make sense?
Yeah, it does. Thanks. Yeah.
Sure. So we'll make this much faster so I can't possibly keep up. Woo! Yeah, I'm awesome. Okay. So the only other thing that we didn't discuss was the gaps. Let me slow that down again.
So the I just want to kind of point out that you have distance in this, but not score. So score could be a completely different element.
Right. I don't know about the listener, the rest of the folks there, but for me, whenever I played an endless runner, your standard endless runner that didn't have like extra mechanics, the only score was how far you made it. Right?
Right.
So for me, my score is going to be around 60 before I'm toast because I don't think my jump's going to extend past that gap there.
Now, speaking of which, and you maybe get to this in just a moment, is the speed at which you travel, does that factor into how far you're able to jump?
Absolutely. Actually, we talked about this a little bit last time, and Sergey said it best, and I wish I could remember how he said it. But one of the difficulties with generating... So an endless runner is what? It's a game where the content that's coming in from the right is, in a sense, generated over time. You don't know what you're going to get. You don't know for sure how tall... Within a range. So my platforms could be 60 pixels tall to 200 pixels tall, and I never know how tall they're going to be or how long they're going to be. They're within the ranges that I set for my random numbers.
You've randomized it.
Right. So last time the question came up, do you make your gaps all the same distance? Or do you make your gaps a different size? And in my implementation for this demonstration, the gaps are always the same width, which is... I just closed the Google window. Hopefully you guys are still there.
Yeah, we're here. We can hear you.
Okay, good. Let's not do that. The gap width is 160 pixels. So I could make this a lot shorter, and then you'd see it.
But you could make them variable so that each time it's a different width, but you want to make sure that you can still bridge the gap.
Right. So, okay, so yeah, I want to address that question. So what's going on here? What are the factors? The factors are the starting height, the ending height that you have to make, and the length of the gap. And I'm not going to be able to talk about the math here, but if you wanted to do it in such a way that you could have any width gap and any height variance, you would have to do a calculation that is, I think it's a calculus calculation, which is basically oh man, what did he call it last week? I kept using the wrong word and I want to use it again. It's not parabolic, it's
I don't know, but that half a semester of calculus that I had 20 years ago is not going to help me out any.
It's a simple calculation, actually. It's just that, once somebody else gives it to you, figuring it out on your own, then you would have some fun. But there's a simple calculation that involves the starting position, x and y, the ending, the velocity, and then the distance, the halfway distance. And you'll be able to figure out, at that point, you'll be able to solve for the highest position that you'll be able to hit still. And then all you do is you find a distance. If you've got the high and the low, you just plug in a value for the distance between until it comes to 0 or greater. So in other words, it matches the equation. It comes out with a real answer.
What are you doing in this particular situation?
So to simplify that, because I didn't want to go through that whole equation, I just said choose a fixed gap, choose a minimum and maximum height, and then what I did was I tested my gap with min followed by a max. So in other words, the lowest platform followed by the highest, and then I just played around with the velocity until I could always make that jump. See what I'm saying? I cheated.
Yep. Yeah. So long as you don't hit it too early, you're always guaranteed to be able to make it.
So if I could always make the lowest to the highest jump at the velocity I set, I was golden. And then I just stuck with those values and went on to do the demo.
Oddly enough, that's the way I approach life.
So that's, it's a good thing you brought that up, because here I am trying to describe the equation to you, and it's not small. I mean, you have to go out there and find it, and you have to understand how to apply it. And you could spend all day or a couple days trying to do that, if depending on your experience level, or you could just say, I kind of know what I'm going to be working with here. I will just do the worst case scenario, and if it works, I'm golden.
Yeah.
And you can do that in like 15 minutes, so you're done.
Yeah, there you go. Yeah,
it's
because
all a question of where you want to spend your energy.
Right. So, okay, the gaps. How do we handle gaps?
The gaps are really nothing special. Let me go ahead and turn them on so you can see them.
Are they actually a thing?
They are, yes. In my case, because I just wanted to use the same mechanics for everything, I made them physics objects. You don't need to do that. So I guess before I even show it, what are the ways we can solve gaps? One of the ways you can solve gaps is you can say, if my player ever drops below a certain y distance, I know that he fell into a gap. Another way to do it, and I hope folks have ideas here besides mine, but another common way to do it, the way I did it, is to make a physics object which is sitting in this gap, and as soon as the foot on my player touches it, I know that I fell into a gap.
So it's kind of a hidden object that the physics engine can figure out if things interact with each other.
Indeed it is. And so
interesting.
Here is my code to create the gap, and all it does is create a rectangle. Let me make this much bigger so you can read it. It creates a rectangle, and then I set it to, I set the fill to, well, it's basically yellow, but then I set the transparency or the alpha to 0. So if I make that 1, it'll show up when I reload. Then I add a body to it, and it's the only thing that's really useful here or for people is it's a kinematic body. And so the 3 kinds of bodies you can have are static, kinematic, and dynamic. And kinematic is like dynamic in the sense that if the object is told to move, the engine knows about it, and it will move it and update its position. Whereas if I made it a static, I could not apply a velocity to it. However, kinematic is special in that no outside forces act on the object. So you'll find yourself in a situation where you would like to have an object that can be told you have a certain velocity or you're rotating at a certain speed, and it does that. So sort of like an internal force. All the set functions. But at the same time, you don't want, when things hit it, to push it out of the way. So like a good example here is these platforms are kinematic. They've been given a linear velocity from right to left, and they're moving. But when the player hits this, there's no response. The player can't push the platform because it's a kinematic object. It does not respond to any of those external forces.
So you can detect a collision, but you don't react to the collision.
Yeah, you can detect a collision, and you can act in a sense like a static object that will hold up another object or prevent an object from impinging upon a space or moving through a space. Okay. But you, as the kinematic object, do not respond to that. So it's like a half-sided physics interaction. Only one of the 2 bodies actually gets the full response.
You set the alpha to 1. Did you save it or did
I haven't reloaded yet? So if I reload it, now you can see my gap.
Or hot lava if you wanted to make it red.
Yeah, or my hot lava. I wish I remember the color code for orange because I would just put that in there for you, Mr. Smart Aleck. So let's turn the foot on too.
There's way too much Minecraft playing.
Let's make the foot visible also, so you can get the full effect here.
Yeah. I have a question for you after you show us how this works, but I don't want to derail.
Okay, hold on 2 seconds here.
Yeah. So I'm glad you defined the kinematic and static and dynamic, because I know that was one of the things that I had to read through several times when I first started looking at the physics engine, going, now what is kinematic? I mean, I kind of get what static is.
It's the wonky one. Everybody has trouble with that.
Yeah, static makes sense.
And then they're like, oh, that's what that does.
Right. Yeah, exactly.
So I've lowered my velocity a whole bunch. Unfortunately, the foot is so tall, it's going to come right off here and touch it. This white block you see is the foot. And we're going to wait. And as soon as that white block touches this, the game is over. It will stop counting, and then the player will fall through, and everything else will keep running. It'll keep generating the platforms. And boom. And that's it. Game over. So that's all there is to it. It's a little physics object attached to my player, the foot that we talked about last week. And the foot is to basically let me know when I'm allowed to jump or not jump. So to prevent air jumping. And then as soon as that foot touches the gap, it triggers a thing to show the game over message, and it tells it stop counting. It sets a flag, is running to false.
So now, okay, so let's, here's the question that I have is, you mentioned that we could have just tracked the Y position and said, okay, if it reaches this point, then he obviously fell in a hole.
Yeah.
What's the difference between using one or the other? Why would I use one over the other? And
why would you want to use one or the other?
or is there a difference?
So if let's say I took the this mechanic, which is all horizontal, no vertical, or very limited vertical to one screen, and let's say that I wanted to do something more like a Mario world that had a fixed bottom, but it could go up and up and up and up and up. You remember how, like in Mario, where you could climb things?
Essentially, the Y changes, the pit changes.
Yeah, but there's always a fixed bottom. There was like that lower where you started running, and that was the bottom of the world forever.
Right.
And then you could go up and up and up and then fall down, but you could still fall in a pit or do something like that. In that case, I could still use the Y. I'm trying to think of a hypothetical scenario. Basically, if
I can see it.
Is going to be always at a fixed location, then you can simply watch for a Y.
Yeah, I could see it. I mean, if you had, like you were talking about, if you were on the ground and then you went to an upper, what is called a second level platform, and in that second level platform you fell in water or something like that.
Right, or like water, or like lava. Let's say I made a lava pit higher up in the world.
Right.
Then I could no longer use the minimum Y rule because the lava pit is above my normal death zone. Does that make sense?
Sure, yeah.
So if I want to be able to kill my player in different places in the world, I need to use some kind of collision mechanic.
I kind of like the term death zone. I'm not sure why.
The death zone's better.
sounds like a groovy T-shirt.
So that's really all there is to it. Just as a reminder, for people who are going to go get this, there are two versions of this encapsulated in the same demo. Let me bring up the folder here. So when you download it, what you're going to see, you're going to see me messing around on the screen trying to get it to look right. Yeah.
Well,
you're going to see a folder.
I was just going to say, and just so everybody knows, we will put a link to this in the show notes as well, so you can go find this because it's there's other goodies that Ed's also shared out there in the GitHub as well.
Yeah, there's a free stuff GitHub. It's got about 35 megs of stuff that you can download and play with. Last time I checked. So you're going to find a main file, and then under scripts, the folder, you'll find 3 files which are for like the ugly version of the game, the basic no art version. And then under the nicer folder, you'll find those same 3 files which have been modified to look a little nicer, whatever. And how do you access those? Let me undo all my changes here. On line 16 of the file, you simply set nicer mode to true or false. So if I set it to false and I reload, instead of this, I will get the uglier version, which is just basically, it shows you a square player with a foot, the platforms, and the gap.
That is
no
the
parallax background.
That is the classic version.
Gear.
Yeah, that's the classic, the almost the Flappy Bird version.
That's Tron. Yeah.
That's
right,
what
and this whole discussion started from Flappy Bird, which is nothing more than a variant of the Endless Runner.
Yes.
With 2 death zones. Things that can kill you all over the place.
That's cool.